So in this diagram you could see that how exactly we are implementing in case of the binary frequency shift key. So data element will be there, then data element like 10110 is going to convert into digital signal with the help of line coding, as we have already discussed. Then we'll use a carrier signal will be used, that will be generated by an oscillator. Then with the help of frequency shift key, as we have already discussed, that frequency shift key means assume if the bit is 1, the frequency will be maintained, then if the bit is 0, the frequency will be reduced. So by multiplying these two things, we'll get the resultant analog signal. So that will be related to your digital signal. Okay, then come to the next one as phase shift key. Phase shift key means, so here we are going to change the phase of the carrier signal. That means phase is nothing but 0 degree, 90 degree, 180 degree, 270 degree, 360 degree, like that. So we'll vary the phase of a carrier signal by maintaining the amplitude and the frequency. So binary phase shift key means we are just considering only two phases of the signal. Rather than considering multiple phases, we'll consider only two phases, something like 0 degree and 180 degree, because both are inverse to each other. Okay, so if you, as an example, you can see that if the digit 0 is there, so we can consider it as 0 degree. If whenever the digit 1 comes, so 180 degree, like that we can change. So we are changing the phase and we will be maintaining the same frequency and the amplitude. And the binary phase shift key is very most frequently will be used because it is less prone to the errors or the noise. So noise is usually can change the amplitude of the signal, but it cannot change the phase of the signal. Okay, and it is also, binary shift key is superior to frequency shift key because we do not require two carrier signal. In case of the phase shift key, we require only one carrier signal. But the disadvantage of phase shift key is we require more hardware in order to distinguish the phases. Okay, how we are going to implement means, so in this diagram you can consider that these are the 10110 are the digital data. Then with the help of the carrier signal, we'll be converting into digital signal. With the help of the line coding, we'll be converting into digital signal. Then we'll consider with the help of the oscillator, will be taken a carrier signal. So when these two are going to multiply with the multiplier devices, we'll get a one modulated signal. So in the diagram you could see the modulated signal has got different phases. So one with the 0 degree, one more with the 180 degree, 0 degree, wherever 1 comes 0 degree, wherever 0 comes 180 degree we have taken. So next comes quadrature phase shift key. That means if we want to send 2 bits at a time, because we can send 1 bit in one signal element, 1 bit in 2 signal element, like that. So if you consider more signal element, then more bandwidth will be required. So always we have to transmit more number of bits in less number of signal element, that we have already discussed as a baud rate. So here we are considering 2 bits, transmitting 2 bits at a time in a single signal element. So thereby we are going to reduce the baud rate, should be always reduced. That means less signal should carry more number of bits. So it is also going to reduce the bandwidth. So how we are exactly implementing means, these are your input. So first, these whatever the bits are there, the bits has to pass through the serial to parallel conversion. We do have 2 oscillators. Okay, 2 oscillators will be there. So first bit will be passing through the first oscillator, and then the next bit will be passing through the next oscillator. So but these 2 oscillators are going to work in a inverse fashion. That means one will be generating the 0 degree phase and another will be generating the 180 degree phase. Okay, 0 and 180 we have taken. So then like this, each bit simultaneously they are going to pass in a parallel fashion. That means one bit in one oscillator, one more in the another oscillator. Then we are going to generate the 2 different carrier signal. Then you try to combine these 2 carrier signal. When we add this carrier signal, we'll be getting the resultant analog signal, which will be related to your digital input or digital signal. And what we'll be getting is for 2-bit informations, so we will be having the 4 different phases with 4 possible phases: 45 degree, minus 45 degree, 135 degree, and minus 135 degree. In that way we try to differentiate these bits, because in the digital manner the bits are differentiated like 0 0 1 0 0 1 1 0. Then how in the analog it is going to differentiate, especially in case of the phase, means 45 degree, minus 45, 35, 135, like that we are going to differentiate. Then constellation diagram which help us to define the amplitude and phase of a signal element, particularly when we are using the two carriers. That means one will be in one phase, another will be one quadrature, that means reverse to that. We are using two carriers, one will be in the 0 degree and another will be in the 180 degree. So diagrammatic representation of that concept of a constellation diagram. So how you could diagrammatically how you can show, means see here, amplitude shift key that we are representing in the constellation diagram. So this is 0, means 0 phase, then 1, only we have got 2 bits, so 0 is also in 0 degree, 1 is also in the 0 degree, both are positive, but only the amplitude is different. Come to the binary phase shift key, both are having the amplitude is positive and negative. Along with that, one you can treat it as 0 degree, another you can treat it in a 180 degree. This way you can treat it like this in terms of the axis, with respect to axis. Okay, when you have considered 4 bits, how you can differentiate? Quadrature phase shift key. If you are considering the two bits each other, so the phases will also be different and the amplitude will also be different. This 0 0, so minus the amplitude is in terms of negative, you can consider. Along with phase will be minus 135, this is plus 135, plus 45, minus 45, like that. So quadrature amplitude is the combination of this. I try to say that rather than considering just the phase, we can combine with the amplitude, so that we'll be getting the quadrature amplitude modulation. Amplitude is a combination of ASK and PSK. That can also be represented like this. You are considering only 2 bits with the unipolar scheme. Again, bits with the polar scheme. Here we have considered the 2 positive levels, that means 2 carriers we are considering and only 2 positive levels. Here you are considering the 8 levels with 4 positive and 4 negative, like that. Okay, thank you.